Shimming your M8 rocker arms. I got the shim kit from Fueling. Right there is the part number. And it comes with an assortment of shims for your rocker arms. I don't think it really matters the manufacturer so much. Pretty much all metals are coming from the same places, and there's only a couple different ways that you can make shims. You can use a surface grinder to grind the material down to the desired thickness, or you can use chemical etching, which is taking sheet metal, put lamination on it, and then you hit it with ultraviolet light to get the shape and size that you want, and then you use chemicals to move away the other materials and reveal the shim that's left over. So is it an expensive process? Yeah, I guess, but does each one of these kits need to be $100? Like, I don't know, so, people can talk all about how Harley is overpriced. Aftermarket manufacturers overpriced. They're all businesses for profit. You just need to enter the dimensions into CAD, plug it into your CNC and let it rip. And that makes 1,000,000 parts. And each one of them's got to be $600. Like, nobody's doing us any favors in terms of that. So, as far as my team's better than your team, this brand, that brand, blah, 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 let's just solve your problem. Hear a lot of things out there about different guesses on what a ticking could be, but if your engine is running good, something's just ticking, it runs, idles fine, it revs up fine, it just ticks, this is likely your problem. You hear a lot of people talk about piston slap. Piston slap is when the clearance between the piston and the cylinder gets so far out of whack that the piston rocks inside the cylinder and creates a knocking and a slapping. You'd have to have a ton of miles on for that to happen. Material just doesn't disappear. It takes a long time, a lot of heat, a lot of expansion, a lot of contraction before that material will actually wear down, give you a lot of clearance in there where it'll slap like that. So it's an easy scare and an easy way to panic people into buying something that they probably don't need. So unless you're really, revving your engine up to 8,000 RPMs and holding it there for hours at a time, and even then, you hear a lot of these guys, the way I ride, like if you're revving that high or you're just beating the shit out of the bike, the chances are the failure is going to be from heat. It's going to heat, the materials are going to swell and expand, and they will seize up. It will not create more distance and start a knocking. So that covers that aspect. The other one I hear is cam bearings. If you change your camshaft, you should definitely change your cam bearing. The stock cam bearing has less rollers in it, and the material in the aftermarket cam bearings are supposedly a lot better material, and they have more rollers in them. The issue is, right underneath your cam bearing is your oil pump. So if that cam bearing does go out, it'll drop right into your oil pump and kaboom, there goes your oil pressure, and that'll lead to other kinds of failure. If it is ticking in there, that means that the rollers, where the camshaft is sitting inside the rollers, it has play in it, and it's smacking around in there. And if that's happening, like I say, you're going to get material right down into your oil pump, and it's going to take out your oiling system, and that'll start causing other problems. The other issue is that if your camshaft is moving inside the cam bearing, you're likely not going to have a good pressure on your lifter, which is not going to give good pressure on your push rod, which is not going to give good pressure on your rocker arm, which is not going to open your valve all the way, and your motorcycle will run like shit. The other one you hear a lot of is lifters. If your lifter goes bad, your lifter is a cylinder with a plunger in it and a spring inside. It has holes on the side that draws oil in there. As that pumps up, it becomes solid, pretty much solid. It's full of oil. It's like a hydraulic jack. Once you jack it up, it's not really going nowhere. If your lifter fails, it'll come apart, obviously, and that'll drop down into your oil pump, take out your oil pump. You'll have a bunch of other problems because you're not oiling. But if it's ticking or if it's making noise, typically the plunger has buried itself down into the cylinder of the lifter body. The push rod will not push all the way, your rocker arm won't push all the way, your valve won't open all the way up, and your motorcycle will run like shit. The other one I hear is push rods. If your push rod is bent or broke, it will not push the rocker arm open all the way. It will not push the valve open all the way, and your motorcycle will run like shit. Same thing with a valve spring, same thing with a valve. Anything happens to those components, you will lose compression and your motorcycle will run like shit. It will not idle right and it will not rev up right. So if your motorcycle is running good, it idles good, it just has a tick to it, this is likely your problem. Let's get into it. Before I take my push rods apart, I want to get a measurement on either end of these rocker arms to see exactly how much clearance I have on either side while there's still pressure on it after the motorcycle's been running. This is the exhaust side, this is the push rod end. I'm going to mark this down. I'm going to stick my gauge in here. And I want to get not only between the rocker arm and the head, but I also want to get all the way to the bushing in there. So if I just measure right here, I'm going to get a particular reading. But if I measure all the way to the bushing, what I got? If I try to go to 12, it doesn't fit. So I know exactly on this side, push rod side, exhaust rocker arm, front jug, that there's 11 thousandths clearance. Now let me check the other side. I have a 0.002. I can just barely get that to fit in there. Let me try this 0.003. That one I kind of have to force it in there. Now I've loosened my push rod. That takes the pressure off the rocker arm. Now, that sound familiar? What do you think happens when it gets running? So now I'm going to go through phase 2 of my measurement. So I've got my dial indicator set up here, and I just want to touch on the flat side of this rocker arm. I'm not quite touching it yet. So I'll turn in toward this until I'm just barely touching it. And then I'll zero my dial. At 0. And I'll push this rocker arm. As I push it, I can see I got about 13, 14 thousandths. Between 13 and 14. Which is exactly what I had on here. Same process on the intake side. Goes in. I'm both hitting the rocker shaft and the bronze bushing. Goes. No go. Let's go to the other side. Now on this side of the intake, so I'm going to go ahead and call that 0. So now I've loosened my intake push rod. That takes the pressure off the rocker arm, and that's the lateral movement. Now I'll take my measurement. Got my rocker arm all the way pushed to one side. I got my gauge zeroed out. 17. .017. So again, I'll mark that down as my total being 0.017. 0.014 on the exhaust and 0.017 on the intake. And you can imagine when it's running, that really sounds like a solid knock. Now you would think as there's pressure on there, when I get the push rods readjusted, they're buried down in the lifter 100 thousandths, that hydraulic is pushing hard on them. And as everything heats up, it should take up a lot of that slack. The issue is not only will you get the knocking of the rocker arm going back and forth laterally while the engine is running, but also your oiling coming up from your push rod, filling this cylinder full of oil to spray onto the valves. So you're going to be losing a little bit of oil pressure in there. So to tighten up the clearance, quiet it down, and improve your oiling, let's shim this thing up. Fueling recommends 0.0035 to 0.0045. So I need to add the appropriate amount of shims. So I'm going to do a little bit of math, determine what shims I'm going to use and where I'm going to put them.